Today we're going to talk about how we can add and subtract like and unlike radicals. So our vocabulary today is radical and radicand. So let's review what a radical is. Okay, a radical can indicate a root. So oftentimes what you've seen is a square root like that. Okay, that means that we're looking for a number that when squared gets you 4. So of course, sometimes this symbol right here is also called the principal square root. Indicating that we want the positive square root. But of course there are two numbers, so for instance the principal square root of 4 is 2. But remember, there are always two numbers that solve this quadratic equation. It's 2 and -2. Okay, so when someone says the principal square root, they want the positive square root. But remember, when you're solving quadratic equations, there's always two numbers that, when squared, gets a positive number. But a radical can also indicate a different type of root. So for instance, if I have a 3 out here, and I put something like 8 inside, this indicates that I'm looking for a number that when cubed, it gets me 8. Okay? And so that number is going to be 2. Oh, and only 2, by the way, because -2 times -2 times -2 gets you -8, not +8. Okay, so a radical symbol can be, so when I don't see anything in this section of this symbol, it means that a 2 is implied, so it means that I'm looking for the square root. But there's all kinds of other roots that you could look for. So for instance, if I put the 4th root in there, like the 4th root of 16, right? So I'm looking for a number that when you multiply it by itself 4 times, I get 16. So that number that I'm thinking about is both 2 and -2. Okay. So when we talk about radical, a radical is this symbol right here. Let me go back here. A radical is this symbol right here, but when I put different numbers in here, like I can put, 1 in there, I can put 2, I can put 3, I can put 4, that means that I'm looking for, the number that's indicated there is how many times you multiply the number to get the number underneath the radical. Okay, now a radicand is the number that's inside the radical. So let's just review. This right here is the radical, and let's say that we're looking for the square root of 4. 4 is called the radicand. Okay, so that's the number. It's a lot like the minuend and subtrahend, right? The minuend is the first part of the subtraction problem, and the subtrahend is the second part. Okay, now the other piece of vocabulary that we should introduce is, and I should have written it for the vocabulary at the beginning, but the index. Okay, the index is the number that's written there. All right. So, for instance, right here, the index is implied to be 2 because we don't write it if it's 2. But for instance, if I took the cube root of 8, right, 3 is the index here. So that's the index. All right. This right there is the radical, and that's the radicand. Okay, so let's look at what we call like and unlike radicals. Like radicals have the same, they have the same index and the same radicand. So they have same index and same radicand. Okay, so indicating that the number in this position, which is 2 for this case, so this is the square root of 7, and then this is, the next one is the 8 times the square root of 7. Now 8 is the coefficient, just like when we have like 8x. 8 is the coefficient. And if the coefficient here is 1, so for instance if I say, oh, the square root of 7, then what I'm implying is that I have one of these square roots of 7. And here I have 8 of these square roots of 7. Okay, so these two are like radicals because they have like radicals, they have like radicands, and they have like indexes. Right? Now, these are like radicals. These next ones are like radicals because I can put a 1 in front and a 7 in front. And the coefficients can be different. But if we look at the indices are the 3 right here. And the radicands are the 5 right here. So since both the 5 and the 3 are the same, the radicands and the indices are the same. They are like radicals. Okay. Now, unlike radicals will be radicals that either have the index is different, or the radicand is different, or both are different. Okay, so these two are unlike radicals because the radicand is different. One has a 5 and one has a 2. Okay, their index is both 2. They're both the square roots of 5 and 2, but their radicand is different. The next ones are different because their index is different. Alright, this one has a 3 and this one is implied to have a 2. So their radicands are the same, 8 and 8, but the type of root that you're taking, this right here is taking the cube root of 8, and this right here is taking the square root of 8. Okay? So this right here is asking the question, what number multiplied by itself 3 times is 8? And this one's asking the question, what number multiplied by itself is 8? Alright, and so of course these x's, and I shouldn't have even represented them both with x's here, this x and y have to be different numbers because you can't multiply a number 3 times and get 8 and then multiply the same number 2 times and get 8. Okay. Now the following ones are unlike because both their index and their radicands are different. So their radicands are 4 and 10, so different. Their indices are 3 and 2. Okay. Now this one has a 9 as a coefficient, this one has a 1 as a coefficient. Right? So let's look at what we can do with like and what we can do with like radicals. Just like we have like terms, we can add like radicals together. So for instance, to add like radicals, we add or subtract their coefficients. Okay? If a radicand is a perfect square, take the square root and multiply it by the coefficient. So for instance, if I have 3, so think of this, it's like 3x plus 5x is equal to 8x. We're all familiar with this by now. So I have 3 of these objects, right? And the objects are the square root of 2. I have 5 of these identical objects, then I get 8 of these identical objects, right? Same thing with this next one. I have 1/2 square roots of 3 plus 6 square roots of 3, so I get 6.5. Oops, that should have been the square root of 3. 6.5 times the square root of 3. Okay, so again, I'm just looking at taking the coefficients here. So I'm looking at taking the coefficients and adding them together. Okay? Okay, so to simplify, if they're unlike, it's possible that we can simplify them to get them so that they're like. So to simplify unlike radicals, the first thing that we're going to do, we're going to go follow the rules that we learned about in the previous section that we went over. And we're going to think about drawing out so we want to break 12 down, but we want to break it down into factors that we want to take out as many perfect squares as possible. So I'm going to break 12 down into 4 times 3, and I'm going to break 75 down into 25 times 3. And then 3 square root of 3 doesn't do anything. Okay, now 4 square root of 3 can be broken down into square root of 4 times the square root of 3 plus, and then I can break this down into their own square roots. Okay. Now 4 square root of 3 is 2, and this is 5 square root of 3 plus 3 square root of 3, and all those together, 2 and 5 is 7. Remember, the indices are the same and the radicands are the same, so those are all like radicals. So I can just add their coefficients. That's 7 and 3 is 10 square root of 3. Okay? So again, we want to simplify with these rules. Now, 1/2 doesn't have a way to, there's no perfect squares that are factors of 1/2, but 20 has 4 as a perfect square. So I'm going to go ahead and do that, split up this into 4 times the square root of 5, plus 16 has, actually 16 is a square root itself, so I can just take that, that's 4, plus 24 has, let's see, the factors of 24 are 8 and 3 and 6 and 4. So 4 is the only perfect square there. So let me put square root of 4 times the square root of 6. Okay, and 2 square root of 1/2. So let's go ahead and do, sort of factor these all in. Plus, alright, there's 2 square root of 5 plus 4 plus 2 square root of 6. Now, there's really nothing else that I can do here because none of the radicands, the indices are all the same for the radicals that I see, but none of the radicands are the same. So I'm just going to have to stop at this point. I can't combine the constant 4 with any other constant because they're coefficients to radicands that are unlike. And so that's about all I can do here. Another trick I could do, but I don't think it would help me, is I could try to combine 2 with, so if I represent 2 in the first one as the square root of 4 times the square root of 1/2, and then I could put them under the same radical, and that would just become 4 times 1/2 is 2, so that would become the square root of 2. So I could make this thing into the square root of 2, but that doesn't help me any. So there's no need to do that because I don't have another square root of 2 that I see. So that's about all I can do. Okay? So that is the end of the lesson today. Let's just review what you learned. You learned how to add radicals that were like. Let me just go back to that page here. Okay, you learned to add radicals that were like, just like you added like terms. You learned how to simplify radicals if they were unlike in order to get them to be like radicals and then add them together. And then you learned how to sort of simplify a large string of addition for radicals, but it's important to know when to stop. And at this point I had to stop this problem. Okay?